right? The properties. Right? The shape, let's start with the shape. Okay, the shape is the same as how we determine, how we determine the shape for the turning point form. So, if A is greater than 0, that's positive, then you're going to have a smiley face. If A is negative, you're going to have a sad face. So that doesn't change. All right? Okay? It's the same thing. Then, number 2, just allow me to introduce the y-intercept first. Okay? Y-intercept. You need to know if you are given the equation of the quadratic function in standard form, what is the y-intercept? Okay? So number 2, we go to the next page. But I can do it here. Okay, I've got space. So number 2, y-intercept. You get this when y or f of x is equal to what? 0. Remember that. You get the y-intercept when what? X is 0. So if I put x equal to 0 here, x equal to 0 here, I just wanted to see this. If I put x equal to 0, x equal to 0, what will be left? C. C. So your y-intercept is always equal to C. Your y-intercept is always equal to C. Okay? Y-intercept is always equal to C. Alright? Then number 3, the x-intercept. Now you get your x-intercept. So I made a mistake here. Please, I'm supposed to put x equal to 0 here. Sorry. I made a mistake here, please. This is supposed to be x equal to 0. You substitute x equal to 0. Please make that correction. Here, you substitute x equal to 0. Because that's the y-intercept. Then, the x-intercept, you substitute y or f of x to 0. Right? So what you do, remember, if the equation is f of x equal to ax squared plus bx plus c, you equate f of x to 0. So, if f of x is equal to 0, therefore means that ax squared plus bx plus c will be equal to 0. Which is a what? It's called a what? What is this equation? Quadratic equation. Right? Then solve the resulting quadratic equation. Okay, remember, you solve the quadratic equation by many ways. So I'll say by 1, factorization if it's possible. Factorization, quadratic formula, which is the best. Right? So you solve by the or you can use a calculator if you want. But you can also solve by completing the square. But I don't think most learners, from my experience, they like this.
So if you do number 2 in 1, you get 2 answers for x.
Yeah, you get 2 values for x.
Just have to get 1.
No. Remember, when you solve the quadratic equation, you must get 2 answers.
So if you're not going to do the completing square, it will be the negative b over 2r.
Yeah, that's the quadratic formula. Okay. But you need to know that sometimes it may be difficult to factorize, so I suggest that you become a master of solving using the quadratic formula. Completing the square is a problem because most learners, from my experience, have got an issue with the technique. Right? So the concept of solving quadratic equations is required when you are dealing with the quadratic function. Are you following that? We did this term 1. We did that term 1. And part of it is also grade 9, grade 10.
So we're going to get 2 x-intercepts.
Yes. You get, in most cases, you get 2 x-intercepts, but sometimes maybe you may get 1. In unique cases, you may not get any x-intercepts.
So what do you do if there's 2? So get one intercept.
For any quadratic function, there are two x-intercepts, maximum 2. But for the y-intercept, it's always 1. Alright, is there anybody who has got any question? Let's move on to x value at the turning point. Now, the x value at the turning point, this is interesting now. X value at turning point. Please, I'm saying x value, I'm not saying coordinates. Okay? X value at turning point. Now, we use an equation. Okay? The equation is x equal, I'm not going to do the derivation of it. Right? But I'll tell you where it comes from. X equal to minus b over 2a. This is the value of x at the turning point. It's given by that. Okay? Next year, when you do what's called calculus, you get a second method of finding this value at the turning point. Right? Now, where does this value come from? Alright, please be aware, this is the value of x at the turning point. It comes from the quadratic formula. Right? X equal to minus b plus or minus b squared minus 4ac over 2a. Do you remember your nature of roots?
No.
What happens? Okay, how can you get one root twice from the quadratic formula? What is, okay, what will be the value of b squared minus 4ac if you are to get one value of x twice?
So there's no x.
The discriminant will be equal to what? Remember, this is called the discriminant. B squared minus 4ac is called the what? The discriminant. Remember, you did nature of roots in term 1. You can't behave like you didn't. Those is going to come back now, just now in November, when you write your November paper. Right? And you also did an investigation on nature of roots.
So I want to know my
Alright, let's get on. Alright, b squared minus 4ac is called the discriminant. So, if b squared minus 4ac is equal to 0, you get one root twice. But what do I mean by that? What it means is, when you solve the quadratic equation, you get two answers that are what? Are the same. That's what this means. You get one root two times. So your x1 will be 2, your x2 will be what? 2. Okay. Now check this. If I were to draw a sketch of a quadratic function like that, if I were to ask you how many x values are at the turning point, what would be your answer? 1. Right? Then how many x values? Let's say the y value here is a specific value. How many x values will you get? 2. There will be 2. There will be an x value here and another x value. So it's only at the turning point where you get one x value. Now we can relate that to nature of roots, whereby we say the discriminant will be equal to 0 if we are to get one root twice. Therefore, this whole part here becomes 0. That square root of b squared minus 4ac. And you'll be left with what? Minus b on top and 2a at the bottom, which is what you have there. So this comes, that's one way. The second way, I don't want to complicate it for you. Yes. Right? I don't want to complicate it for you, so you just need to know that the x value at the turning point for the standard form is equal to x equal to minus b over 2a. Now, someone might be asking, how do I get the y value? Okay? Substitute the x value x value into the original equation to determine the y value at the turning point. So what I'm saying is, this x value, you substitute back into the quadratic equation, which is in standard form, to get the y value. Turning point. Okay, it's not complicated. So you get your x value first, and you just have to identify your b, which is something that you know from term 1, identify your a, which is something that you know from term 1, simplify that, get your x value. Then substitute that x value into the standard form, get the y value. Then you'll have been able to determine your turning point. Okay. Then let's move on to equation of axis of symmetry. Now, the good thing is that the x value at the turning point is related to the equation of axis of symmetry. So, number 5, let me do it on the next page. Number 5, equation of line of symmetry. Okay, let me say line of symmetry. That equation is also equal to the x value at the turning point. So it's x equal to minus b over 2a. So this is the equation of the line of symmetry. The x value at the turning point is also gives you the x value at the line of symmetry or along the line of symmetry. Okay. And after that, you can now sketch.
So that's the turning point.
Okay. You can now sketch. Right.